Introduction to Supply Chain Management. Supply Chain Management, SCM, encompasses the comprehensive oversight of goods, services, and information flow, from raw material acquisition to final product delivery to the consumer. It involves coordinating and integrating these flows, both within and among companies, aiming to optimize efficiency and customer satisfaction. Effective SCM is crucial for businesses to remain competitive, reduce costs, and respond swiftly to market changes. It is a strategic function that impacts every aspect of a company's operations and its ability to deliver value. The importance of SCM has grown significantly due to globalization, technological advancements, and increasing customer expectations. A well-managed supply chain can provide a distinct competitive advantage, enabling companies to deliver products faster, at lower costs, and with higher quality. It also plays a vital role in managing risks, ensuring business continuity, and fostering sustainable practices across the entire network. Understanding SCM fundamentals is essential for any professional involved in operations, logistics, or procurement. Key components of a supply chain. A typical supply chain consists of several key components that work in concert to deliver products and services. These components include planning, strategic decisions on how to manage resources to meet demand; sourcing, selecting suppliers to provide goods and services; manufacturing, producing the goods, including scheduling and quality control; delivery, logistics and transportation to get products to customers; returns, managing product returns and reverse logistics. Each component is interdependent, and a breakdown in one area can affect the entire chain. Information flow is another critical component, connecting all stages of the supply chain. This includes data on demand, inventory levels, production schedules, and delivery status. Effective information sharing ensures transparency and enables quick decision-making. Financial flow, encompassing payments, credit terms, and consignment, also moves through the supply chain, supporting transactions and managing costs. The integration of these flows is vital for a seamless and responsive supply chain operation. Evolution of supply chain management. The concept of supply chain management has evolved significantly over several decades, moving from a fragmented view of individual functions to a holistic, integrated approach. Initially, businesses focused on optimizing individual departments like purchasing, production, and logistics in isolation. This siloed approach often led to inefficiencies and a lack of coordination across the entire operational flow. Early efforts were primarily concerned with cost reduction within each specific function, without considering the broader impact on the entire chain. The shift towards an integrated SCM approach began in the late 20th century, driven by increased global competition and advancements in information technology. Companies started recognizing the benefits of managing the entire flow of goods and information as a single system. This evolution led to the development of sophisticated SCM strategies, emphasizing collaboration, visibility, and responsiveness across all partners. Today, SCM continues to evolve with the advent of digital technologies like AI, blockchain, and IoT, transforming traditional supply chains into intelligent, adaptive networks. Goals and objectives of SCM. The primary goals of supply chain management are multifaceted, aiming to achieve a delicate balance between efficiency, cost-effectiveness, and customer satisfaction. One core objective is to minimize total supply chain costs, which includes expenses related to procurement, manufacturing, inventory holding, and transportation. By optimizing these areas, companies can enhance their profitability and allocate resources more effectively. Another key goal is to improve efficiency and productivity across all stages of the supply chain, ensuring smooth operations and reduced waste. Beyond cost and efficiency, SCM also focuses on enhancing customer service by ensuring timely delivery, product availability, and responsiveness to customer needs. Building resilience and agility into the supply chain is increasingly important to mitigate risks and adapt to disruptions, such as natural disasters or geopolitical events. Furthermore, modern SCM objectives often include promoting sustainability and ethical practices, ensuring responsible sourcing and environmental stewardship throughout the entire product lifecycle. Achieving these goals requires continuous optimization and strategic alignment. Aligning SCM with business strategy, effective supply chain management is not merely an operational function. It must be strategically aligned with the overall business objectives to maximize impact. This alignment ensures that supply chain decisions support the company's competitive priorities, whether they are cost leadership, differentiation, or rapid response. For example, a company focused on cost leadership will design a lean and efficient supply chain, while a company emphasizing differentiation might prioritize flexibility and innovation in its supply chain design. Misalignment can lead to wasted resources and missed market opportunities. The process of aligning SCM with business strategy involves understanding the company's value proposition and translating it into specific supply chain capabilities. This requires close collaboration between SCM leaders and other functional areas, including marketing, finance, and product development. Regular strategic reviews and performance monitoring are essential to ensure that the supply chain continues to support evolving business goals. A well-aligned supply chain becomes a powerful enabler of competitive advantage and sustainable growth for the organization. Supply chain network design. Supply chain network design involves making strategic decisions about the physical configuration of the supply chain, including the number, location, and capacity of facilities such as manufacturing plants, warehouses, and distribution centers. These decisions have long-term implications for costs, service levels, and responsiveness. Factors influencing network design include customer locations, supplier locations, transportation costs, labor availability, and tax regulations. An optimal design minimizes total system costs while meeting customer service requirements. The process typically involves analyzing current and future demand patterns, evaluating potential facility sites, and modeling different network configurations using advanced analytical tools. Considerations also extend to inventory placement strategies and the assignment of customers to specific distribution centers. A well-designed network enhances operational efficiency, reduces lead times, and improves overall supply chain performance. It is a complex undertaking that requires careful planning and a deep understanding of logistical trade-offs. Global supply chain considerations. Operating a global supply chain introduces a unique set of complexities and challenges compared to domestic operations. Companies must navigate diverse regulatory environments, customs procedures, and international trade agreements. Currency fluctuations, geopolitical risks, and cultural differences also add layers of complexity to sourcing, manufacturing, and distribution decisions. Managing these factors effectively requires specialized expertise and robust risk management strategies. Furthermore, global supply chains often involve longer lead times and more intricate transportation networks, increasing the potential for disruptions. Companies must consider various modes of international transport, such as ocean freight, air freight, and rail, each with its own cost and speed implications. Ensuring visibility across the entire global network, from distant suppliers to overseas customers, is paramount for effective management. Leveraging technology and fostering strong international partnerships are key to successfully managing global supply chain operations. Supply chain risk management. Supply chain risk management involves identifying, assessing, and mitigating potential disruptions that could impact the flow of goods, information, and finances. Risks can stem from various sources, including natural disasters, geopolitical instability, supplier failures, cyber attacks, and sudden demand shifts. The consequences of unmanaged risks can be severe, leading to production delays, increased costs, reputational damage, and loss of customer trust. Proactive risk management is crucial for maintaining business continuity. Developing a robust risk management strategy includes several steps. Risk identification, mapping the supply chain to pinpoint vulnerabilities. Risk assessment, evaluating the likelihood and impact of identified risks. Risk mitigation, implementing strategies to reduce exposure, such as diversification of suppliers or inventory buffers. Contingency planning, developing recovery plans for when disruptions occur. Monitoring and review, continuously tracking risks and updating strategies. This systematic approach helps build a resilient and adaptive supply chain capable of withstanding unforeseen events. Understanding demand management. Demand management is a critical process within supply chain management that focuses on influencing and predicting customer demand to match it with supply capabilities. It involves understanding customer needs, market trends, and external factors that affect product or service consumption. Effective demand management helps companies avoid stockouts, minimize excess inventory, and optimize production schedules. It is a proactive approach that goes beyond simply reacting to orders. Key activities in demand management include demand forecasting, predicting future customer demand, demand planning, developing strategies to meet forecasted demand, demand shaping, influencing demand through pricing, promotions or product introductions, order management, processing and fulfilling customer orders efficiently. By integrating these activities, businesses can achieve better alignment between sales, marketing, and operations, leading to improved customer satisfaction and profitability. It requires continuous analysis and adaptation to market dynamics. Forecasting techniques and methods. Accurate demand forecasting is fundamental to effective supply chain management, enabling companies to make informed decisions about production, inventory, and resource allocation. Various techniques and methods are employed, broadly categorized into qualitative and quantitative approaches. Qualitative methods rely on expert judgment and subjective insights, often used when historical data is scarce or for new product introductions. These include market research, Delphi method, and Salesforce composite. Quantitative methods, on the other hand, use historical data and mathematical models to predict future demand. These include time series analysis, identifying patterns like trends, seasonality, and cycles in past data. Causal models, using independent variables, e.g., economic indicators, promotional activities, to predict demand. Common time series techniques include moving averages, exponential smoothing, and ARIMA models. The choice of forecasting method depends on data availability, forecast horizon, and desired accuracy. Combining multiple methods often yields more robust predictions. Sales and Operations Planning (S&OP). Sales and Operations Planning (S&OP) is an integrated business management process that helps companies align their sales and marketing plans with their production and supply chain capabilities. It is a cross-functional planning process, typically conducted monthly, that brings together representatives from sales, marketing, operations, finance, and product development. The goal is to create a single, unified plan that balances demand and supply, ensuring that the company can meet customer needs profitability. The S&OP process typically involves several key steps: data gathering, collecting sales forecasts, inventory levels, and production capacities; demand planning, reviewing forecasts and making adjustments; supply planning, assessing production capabilities and resource availability; pre-S&OP meeting, reconciling demand and supply plans; executive S&OP meeting, making final decisions and approving the integrated plan. Effective S&OP improves communication, reduces inventory costs, enhances customer service, and supports strategic decision-making across the organization. Collaborative Planning, Forecasting and Replenishment (CPFR). Collaborative planning, forecasting, and replenishment (CPFR) is a business practice that combines the intelligence of multiple trading partners in planning and fulfilling customer demand. It is a voluntary process where retailers, manufacturers, and distributors work together to create shared forecasts and replenishment plans. The goal of CPFR is to improve supply chain efficiency and effectiveness by reducing inventory, improving forecast accuracy, and enhancing customer service through better collaboration. The CPFR model typically involves 4 key activities: strategy and planning, establishing business goals and collaboration agreements, demand and supply management, forecasting consumer demand and identifying exceptions, execution, generating orders and managing shipments, analysis, monitoring performance and identifying areas for improvement. By sharing information and coordinating activities, partners can achieve a more synchronized and responsive supply chain, leading to mutual benefits and stronger business relationships. It represents a significant step towards true supply chain integration. Strategic sourcing process. Strategic sourcing is a systematic and data-driven approach to purchasing goods and services that focuses on long-term value creation rather than just short-term cost reduction. It involves analyzing spending patterns, market conditions, and supplier capabilities to identify opportunities for cost savings, quality improvements, and risk mitigation. This process moves beyond transactional purchasing to build sustainable relationships with key suppliers. It is a continuous process that requires ongoing evaluation and adaptation. The strategic sourcing process typically involves several key steps: spend analysis, understanding what is being purchased and from whom; market research, identifying potential suppliers and market trends; supplier evaluation and selection, assessing suppliers based on criteria like quality, cost, and reliability; negotiation, establishing favorable terms and conditions; contract management, overseeing supplier performance and compliance; continuous improvement, monitoring and optimizing supplier relationships. By following these steps, organizations can achieve significant improvements in their procurement operations and overall supply chain performance. Supplier Relationship Management, SRM, is a systematic approach to evaluating and managing supplier interactions and performance to maximize value from these relationships. It moves beyond transactional purchasing to foster collaborative partnerships with key suppliers. The goal of SRM is to develop stronger, more strategic relationships that drive innovation, reduce costs, and mitigate risks for both parties. Effective SRM recognizes that suppliers are critical extensions of an organization's own capabilities. Key activities in SRM include supplier segmentation, categorizing suppliers based on their strategic importance; performance management, monitoring and evaluating supplier performance against agreed-upon metrics; relationship building, fostering trust and open communication; joint innovation, collaborating on new product development or process improvements; risk management, addressing potential disruptions in the supplier base. By investing in SRM, companies can unlock greater value, improve supply chain resilience, and gain a competitive edge in the market. Ethical and sustainable procurement involves integrating social, environmental, and ethical considerations into the purchasing process. This goes beyond traditional criteria like cost and quality to ensure that goods and services are sourced responsibly. Companies are increasingly expected to demonstrate transparency and accountability for the practices of their suppliers, driven by consumer demand, regulatory pressures, and a commitment to corporate social responsibility. It is about making purchasing decisions that benefit society and the environment. Key aspects of ethical and sustainable procurement include fair labor practices, ensuring no child labor, forced labor, or unsafe working conditions; environmental stewardship, minimizing ecological footprint, reducing waste, and promoting resource efficiency; transparency, tracing the origin of materials and manufacturing processes; community impact, supporting local economies and fair trade initiatives. Implementing these practices requires thorough supplier audits, robust codes of conduct, and continuous engagement with the supply base. This approach not only mitigates risks, but also enhances brand reputation and fosters long-term value. Global sourcing challenges. While global sourcing offers significant benefits such as cost reduction and access to specialized resources, it also presents a myriad of challenges. One major challenge is managing extended lead times and increased transportation costs, which can impact inventory levels and responsiveness. Quality control becomes more complex when dealing with suppliers across different countries with varying manufacturing standards and regulatory oversight. Ensuring consistent product quality requires rigorous inspection and audit processes. Other significant challenges include navigating complex customs regulations, tariffs, and trade barriers, which can delay shipments and increase landed costs. Geopolitical risks, currency fluctuations, and intellectual property protection are also critical concerns that must be carefully managed. Cultural and communication differences can hinder effective collaboration and problem-solving with international suppliers. Overcoming these challenges requires robust risk management, strong supplier relationships, and a deep understanding of international business practices. Production planning and scheduling. Production planning and scheduling are crucial activities within manufacturing operations that determine what products to produce, when to produce them, and with what resources. Production planning involves long-term strategic decisions about capacity, facility layout, and aggregate production levels. It aims to match overall demand with production capabilities, ensuring that the company can meet its sales targets while optimizing resource utilization. This foundational step sets the stage for detailed scheduling. Production scheduling, on the other hand, deals with the short-term, tactical allocation of specific jobs to machines and workers over a defined period. It aims to optimize factors like lead times, inventory levels, and machine utilization. Key objectives include minimizing setup times, reducing work-in-process inventory, and ensuring on-time delivery. Advanced scheduling techniques and software are often employed to manage complex manufacturing environments, balancing competing priorities and responding to real-time changes on the factory floor. Inventory management strategies. Inventory management involves overseeing the ordering, storage, and use of components and products. It is a critical function in supply chain management, aiming to strike a balance between having enough inventory to meet customer demand and minimizing the costs associated with holding excessive stock. Poor inventory management can lead to stockouts, lost sales, or high carrying costs, impacting profitability and customer satisfaction. Effective strategies are essential for operational efficiency. Various inventory management strategies are employed to optimize stock levels. Just-in-time, JIT, minimizing inventory by receiving goods only as they are needed. Economic order quantity, EOQ, calculating the optimal order size to minimize total inventory costs. ABC analysis, categorizing inventory items based on their value and importance. Vendor-managed inventory, VMI, suppliers take responsibility for managing inventory at the customer's location. The choice of strategy depends on factors like product characteristics, demand variability, and lead times. Leveraging technology and data analytics is key to implementing these strategies effectively. Lean and agile manufacturing. Lean manufacturing is a systematic method for minimizing waste within a manufacturing system without sacrificing productivity. It focuses on identifying and eliminating non-value-added activities such as overproduction, waiting, unnecessary transport, overprocessing, excess inventory, unnecessary motion, and defects. The core principle is to create more value for customers with fewer resources. This philosophy originated from the Toyota production system and has been widely adopted across industries. Agile manufacturing, in contrast, emphasizes flexibility and responsiveness to rapidly changing customer demands and market conditions. It focuses on quickly adapting production processes, product designs, and supply chain configurations to meet new requirements. While Lean aims for efficiency, Agile prioritizes speed and adaptability. Many companies strive for Legile supply chains, combining the cost-effectiveness of Lean with the responsiveness of Agile. This hybrid approach allows businesses to optimize both efficiency and flexibility in their operations. Quality management in operations. Quality management in operations is a comprehensive approach to ensuring that products and services consistently meet or exceed customer expectations. It involves establishing quality standards, implementing processes to achieve those standards, and continuously monitoring and improving performance. Poor quality can lead to customer dissatisfaction, costly rework, warranty claims, and damage to brand reputation. Effective quality management is integral to operational excellence and customer loyalty. Key principles and tools in quality management include Total Quality Management, TQM, a holistic approach involving all employees in continuous improvement. Six Sigma, a data-driven methodology for reducing defects to near zero. ISO 9001, International Standards for Quality Management Systems. Statistical Process Control, SPC, using statistical methods to monitor and control processes. Implementing these practices requires a culture of quality, robust training, and a commitment to continuous improvement. By embedding quality throughout the entire operational process, companies can deliver superior products and services consistently. Transportation management. Transportation management is the process of planning, executing, and optimizing the physical movement of goods from one location to another. It is a critical component of logistics, directly impacting costs, delivery times, and customer satisfaction. Effective transportation management involves selecting the right modes of transport, optimizing routes, managing carriers, and ensuring compliance with regulations. It aims to deliver products efficiently and reliably while minimizing expenses. Key aspects of transportation management include mode selection, choosing between road, rail, air, sea, or intermodal transport. Route optimization, finding the most efficient paths for deliveries. Carrier management, selecting, contracting, and managing relationships with transportation providers. Freight consolidation, combining smaller shipments into larger ones to reduce costs. Visibility and tracking, monitoring shipments in real time. Leveraging transportation management systems, TMS, and real-time data analytics is essential for optimizing these complex operations and responding to dynamic conditions. Warehousing and distribution centers are essential nodes in the supply chain, serving as storage and transfer points for goods. Warehouses primarily focus on long-term storage and inventory management, while distribution centers are designed for faster throughput, consolidating products from various suppliers and quickly distributing them to customers. Both play a critical role in ensuring product availability, managing inventory, and facilitating efficient order fulfillment. Their strategic location and efficient operation are key to supply chain performance. Key functions of warehouses and distribution centers include receiving, unloading and inspecting incoming goods, storage, organizing and holding inventory, order picking, retrieving specific items for customer orders, packing, preparing orders for shipment, shipping, loading outgoing goods onto transportation vehicles. Modern facilities often leverage automation, robotics, and advanced warehouse management systems, WMS, to optimize these processes, improve accuracy, and reduce operational costs. The design and operation of these facilities significantly impact overall logistics efficiency. Reverse logistics and returns management. Reverse logistics encompasses all operations related to the reuse of products and materials, including returns, repairs, recycling, and disposal. It is the process of moving goods from their typical final destination for the purpose of capturing value or proper disposal. Historically, companies focused primarily on forward logistics, but the increasing volume of returns, environmental regulations, and consumer demand for easy returns have made reverse logistics a critical area of supply chain management. It is no longer just a cost center, but a potential source of value. Effective returns management involves collection, efficiently gathering returned products from customers, inspection and sorting, assessing product condition for repair, refurbishment, or recycling. Processing, handling refunds, exchanges, or credits. Disposition, determining the best end-of-life option for the product. A well-managed reverse logistics system can improve customer satisfaction, recover value from returned goods, reduce waste, and enhance a company's sustainability efforts. It requires dedicated processes and often specialized facilities to handle the complexities of product returns. Last-mile delivery and e-commerce logistics. Last-mile delivery refers to the final leg of a product's journey from a distribution center or hub to the end customer's doorstep. It is often the most complex, time-consuming, and expensive part of the supply chain, accounting for a significant portion of total shipping costs. The rise of e-commerce has dramatically increased the importance and challenges of last-mile delivery, as customers expect fast, flexible, and often free shipping options. Optimizing this stage is crucial for customer satisfaction and profitability. E-commerce logistics encompasses the entire supply chain process for online retail, from inventory management and order fulfillment to packaging and delivery. Key challenges include managing fluctuating demand, handling a wide variety of product sizes and weights, and offering diverse delivery options, e.g., same-day, scheduled, click and collect. Innovative solutions like drone delivery, autonomous vehicles, and micro-fulfillment centers are emerging to address these complexities. Effective e-commerce logistics requires seamless integration of technology and a customer-centric approach. Measuring supply chain performance, KPIs. Measuring supply chain performance is essential for identifying areas for improvement, tracking progress, and ensuring that strategic objectives are met. Key performance indicators, KPIs, provide quantifiable metrics to evaluate the efficiency, effectiveness, and financial health of the supply chain. Without proper measurement, it is difficult to assess the impact of initiatives or make data-driven decisions. A balanced set of KPIs offers a holistic view of performance. Common supply chain KPIs include on-time delivery, percentage of orders delivered by the promised date, inventory turnover, how many times inventory is sold and replaced over a period, order fulfillment cycle time, time from order placement to delivery, perfect order rate, orders delivered complete, on time, damage-free, and with accurate documentation, supply chain costs, total expenses related to procurement, production, and logistics, supplier defect rate, percentage of defective items from suppliers. Regularly monitoring these KPIs allows organizations to benchmark against industry standards, identify bottlenecks, and drive continuous improvement across the entire supply chain. Supply chain technology and digitalization. The digitalization of supply chains is transforming traditional operations, enabling greater visibility, efficiency, and responsiveness. Advanced technologies are empowering businesses to collect, analyze, and act on vast amounts of data, leading to more informed decision-making and optimized processes. This technological revolution is reshaping how goods are sourced, produced, moved, and delivered, creating intelligent and interconnected supply chain ecosystems. Embracing these technologies is crucial for competitive advantage. Key technologies driving supply chain digitalization include artificial intelligence, AI, and machine learning, ML, for predictive analytics, demand forecasting, and automation. Internet of Things, IoT, for real-time tracking of assets, inventory, and environmental conditions. Blockchain, for enhanced transparency, traceability, and security across the network. Robotics and automation, for optimizing warehouse operations and manufacturing processes. Cloud computing, for scalable data storage and collaborative platforms. These technologies, when integrated, create a resilient, agile, and highly efficient digital supply chain, capable of navigating complex global challenges and meeting evolving customer expectations.